Hi there, Kanika here, and welcome back to another episode of Kaggle Competition Chronicles. Today we're diving into 2024 Kaggle Playground Series, a competition that's as intriguing as it is educational. This month we're tackling the binary prediction of whether a mushroom is edible or poisonous based on its physical characteristics, something that could be quite handy if you're ever foraging in the wild. Sounds fun, right? I'll walk you through the entire process of exploring data, preparing it for modeling, ultimately making predictions, and we'll cover everything from handling missing data to feature scaling, and I'll share some insights from my own experiences along the way. So let's get started. This month's challenge is all about predicting whether mushrooms are edible or poisonous. Our task is to build a model that can predict these predictions based on various physical characteristics of the mushrooms, such as cap shape, color, and whether it bruises or not. Now, how do we measure success? Submission will be evaluated on Matthew's correlation coefficient, or MCC for short. MCC is particularly useful in binary classification, especially when the classes are imbalanced. So you will see it's perfect for this challenge. Just a quick note, this competition runs for a month, so we have plenty of time to experiment, iterate, and fine-tune our models. Alright, let's jump into the dataset. We have two mains files, training set, which we'll use to build our model, and test set, which we'll use to evaluate it, and a submission sample file, according to which we'll craft our submission file. I like to start by looking at the dataset, taking a quick look at the first few rows to get the feel of what we're dealing with. Next up, we'll check the data types to look for any missing values. This is where you start to get sense of the dataset's structure. What's numerical, what's categorical, whether we might need to do some cleaning. Missing values are inevitable, but there's nothing we can't handle. Before we dive into data preparation, it's essential to understand our target variable, whether the mushroom is edible or poisonous. A quick count plot will show us how balanced the classes are. If one class heavily outweighs the other, it might influence how we approach our modeling later. Now, missing data can be a tricky part of processing, but knowing where those gaps are is half the battle. We'll print out a summary of missing values in each column, which will guide our imputation strategy and next steps. Now, let's get to work. We'll start by separating our features from target variables, which is the class. I also like to distinguish between numerical and categorical columns early on. This helps me streamline the rest of the data preparation process. Missing values are like one of those friends who always cancel last minute. You can't avoid them, but you can plan for them. For numerical columns, I'm filling the gaps with mean. It's a simple approach, but it keeps our data consistent. For categorical column, I'm using the mode, the most frequent value, works best in general, ensuring that we don't skew the data. During my initial exploration, I noticed that some outliers, particularly in the numerical feature, so instead of using standard scaler, which might throw off these outliers, I'm going to use RobustScaler. This scaler is less sensitive to outliers and ensures that our model treats all features fairly. Now, as we explore the categorical variables, it is clear that many of these categories have high cardinality. Lots of unique values. This presents a challenge, especially since I found that the test set contains some unique values not present in the training set. To handle this, I opt for feature hashing, an encoding technique which efficiently manages the cardinality and helps us avoid potential issues with unseen categories in the test set. Before we train our model, it is important to split our data into training and validation set, which I'm calling test set here. This allows us to test the model's performance on unseen data, which is critical for ensuring that it generalizes well beyond the training set. I'm going to label encode my target variable, which I will have to decode before submitting the file. With our data ready, it's time to train the model. I'm using RandomForestClassifier, a reliable, robust choice for classification task. After training, I'll evaluate the model using Matthew's correlation coefficient. MCC is especially useful here because it gives a better picture on how well our model is handling both classes, even if they are imbalanced. Okay, so that's our score, and now I'm going to train the model on the whole training set, combining the validation and training set that I previously split it. Now for the final stretch, making prediction on test set using model we just trained. I'll predict the class label for each mushroom in the test set. We then decode these predictions back to the original labels using our label encoder. Finally, we prepare the prediction for submission. This involves saving them, formatted according to the competition guidelines. Remember, this file is your entry ticket to the leaderboard, so double check everything before submitting. So there you have it, a full walkthrough of exploring and preparing data for the Playground monthly competition. From understanding the data, handling missing values, and managing outliers, to training a robust model and making predictions, we've covered it all. Every step we took, whether it was deciding to use RobustScaler after spotting the outliers or choosing feature hashing due to high cardinality, even selecting the number of features in feature hashing, was influenced by what data told us. The key to success in these competitions is let the data guide your decisions. If you found this helpful, well, watch along. I am coming up with some more competition-specific videos in the Kaggle Competition Chronicles, and best of luck for your submissions. I'll see you on the leaderboard.